To solve this problem, we're going to apply this formula and the Lambert W function, which states that the W function of x exponential x is equals to x. So for example, if I have the W function of 2 exponential 2, this is simply going to give us 2. So we're going to apply these functions and these formulas to solve this problem. Subtracting x from both sides, we're going to have 3 to the power of x is equals to 6 minus x. And if we divide both sides by 3 to the power of x, 3 to the power of x, we're going to have here is going to give us 1 is equals to 6 minus x. And we can multiply this by 3 to the power of negative x. Alright? And if we push it to the right, we'll have just the same thing, 6 minus x times 3 to the power of negative x. This is equals to 1. So the idea here is I'm going to try to transform this to be of the form of the Lambert W function trick, so we can apply this function. So what do? We multiply both sides by 3 to the power of 6. And if we do that and we rearrange this, we're going to have negative x plus 6 times 3 to the power of negative x times 3 to the power of 6. And this is 3 to the power of 6. By indices, we're just going to add the powers of these two since it has the same base. So we're going to have negative x plus 6, 3 to the power of negative x plus 6. And this is 3 to the power of 6. Next, we're going to apply this. And applying it here, we know that exponential natural log of 3 is same as 3. So we're going to replace this theory with exponential natural log of 3. And if we do that, we're going to have so this is what we're going to have. And we can distribute the powers of the exponential. And we're going to have negative x plus 6 exponential negative x plus 6 natural log of 3. This is equals to 3 to the power of 6. Then we can multiply both sides by natural log of 3 times natural log of 3. And if we do that, we're going to have negative x plus 6 times natural log of 3, then times exponential negative x plus 6 times natural log of 3, and this is going to give us 3 to the power of 6 natural log of 3. So we've changed nothing, but if you look at this clearly, you can now see that this term is same as this term here. So we have successfully made the left side to be in this form. So next we apply the Lambert W function to both sides. This is going to be negative x plus 6 natural log of 3 exponential negative x plus 6 natural log of 3 equals to the Lambert W function of 3 to the power of 6 natural log of 3. So since this and this are the same thing, this is simply going to give us negative x plus 6 natural log of 3. And this will be equals to the Lambert W function of 3 to the power of 6 natural log of 3. So give us negative x plus 6 is equals to the Lambert W function of 3 to the power of 6 natural log of 3 all over natural log of 3. And after a little algebra, we'll have that our x will be equals to 6 minus the W function of 3 to the power of 6 natural log of 3 all over natural log of 3. And this is a good enough solution, but we're going to go further to find the actual value of x. To do that, we're going to find the value of 3 to the power of 6 times natural log of 3, which is approximately 800.8884. So to find the Lambert W function of this, we're going to use the Lambert W function calculator. We've been able to find this to be 5.063637. So next we substitute this value to replace this in the expression to find our x. So we're going to have that x is going to be 6 minus 5.063637 all over natural log of 3. So x is equals to 6 minus, this is actually 4.60912. So our x is approximately equals to 1.3909, and that solves your problem. So if you go ahead and substitute x here to be 1.3909, we are definitely going to get this value 6. Thank you guys.